What if you could run your code without ever thinking about a server? No machine to launch, no operating system to patch, nothing sitting there idling and costing money while it waits for something to happen. You just write a function, hand it to AWS, and say, run this whenever this thing happens. That's AWS Lambda, and it's the headline act of something called serverless computing. Let's break it down. First, let's clear up the most confusing word, serverless. It does not mean there are no servers. Of course there are. Your code has to run on something. What it means is that you don't manage, provision, or even think about those servers. AWS handles all of that, completely out of sight. With a traditional server, you rent a machine and it runs around the clock, whether it's busy or not, and you pay for all that time. With serverless, there's nothing running until your code is actually needed. AWS spins it up the instant something triggers it, runs it, and tears it down. You pay only for the moments your code is actually executing. So, serverless really means server managed by someone else and invisible to you. That shift changes everything about how you build. The basic unit of Lambda is the function. A function is just a piece of code that does one specific job. Resize an image, process a form submission, send a confirmation email. You write that code, upload it to Lambda, and that's your function. Ready and waiting, but not running and not costing you anything until it's called. This is a different mindset from a big, always-on application. Instead of one giant program running continuously, you have lots of small, focused functions, each springing to life only when it's needed. Small, single purpose, on demand. But a function just sitting there does nothing. Something has to set it off. That something is a trigger. A trigger is the event that causes your function to run, and the range of possible triggers is what makes Lambda so powerful. A few examples: a file gets uploaded to storage, run a function to process it. Someone visits a web address, run a function to respond. A timer goes off every morning at 9 a.m., run a function on a schedule. Another AWS service does something, run a function to react. So you're essentially wiring up rules. When this happens, run that function. Lambda sits quietly in the middle of your system, listening, and springs into action the moment a trigger fires. When a trigger fires, it doesn't just wake your function up empty-handed. It hands over an event. An event is a packet of data describing what happened. If the trigger was a file upload, the event includes details like which file and which storage location. If it was a web request, the event includes the details of that request. Your function receives this event as its input, looks at it, and does its job based on what's inside. So the flow is simple and clean. A trigger fires, it passes an event, your function reads the event and acts on it. Trigger, event, function. That's the whole rhythm of Lambda. Lambda is brilliant, but it's designed for short, snappy tasks. And it has two limits that make that clear. The first is a timeout. A Lambda function can run for a maximum of 15 minutes before AWS stops it. That tells you what it's for. Quick jobs, not hours-long number crunching. If something needs to run for a long time, Lambda is the wrong tool. The second is memory. You choose how much memory your function gets, up to a generous ceiling, and that allocation also affects how much processing power it has. More memory, more speed, and a slightly higher cost while it runs. These aren't really restrictions so much as a description of Lambda's sweet spot. Short, focused tasks that start fast and finish fast. There's one quirk worth knowing about because you'll hear the term, the cold start. When your function hasn't run in a while, there's nothing ready and waiting. So the very first time it's triggered, AWS has to set up a fresh environment to run it in. And that setup adds a small delay, often a fraction of a second. That's a cold start. Once it's running, AWS keeps that environment warm for a bit, so the next requests are instant. Cold starts only hit that first, out-of-the-blue invocation. For most uses, it's completely unnoticeable, but it's good to know what people mean when they grumble about them. Let's stack it up. With Lambda, you write a function, a small piece of code for one job. You attach a trigger, the event that sets it off. When it fires, your function receives an event describing what happened and acts on it. It runs within a timeout and a chosen amount of memory, occasionally with a tiny cold start delay. And you pay only for the time it actually runs. No servers to manage, nothing idling. Just code that runs when it's needed. That's Lambda, serverless computing, where you bring the code and AWS handles the rest. If this made serverless click, hit subscribe. We're breaking down AWS one service at a time. And drop the next service you want explained in the comments. See you in the next one.